My name is Sheri Johnson, and my colleague Merve Kursov and we met about 10 years ago at University of Georgia, where I was working on my PhD in mathematics education. And prior to this, I studied engineering and worked with a lot of data on the business side of healthcare. Merve went on to finish her PhD in mathematics education also at Michigan State University and is now a research associate at Dartmouth College, where she's working on a really cool project. It's an NSF funded grant, Diffuse, and we'll be taking a closer look at that. We're going to share a copy of these slides by dropping a link in the chat. And you can also always email us or look us up on LinkedIn and reach out. We're happy to help people learn about data science. So we only have 20 minutes together. We hope you will come away with a better understanding of the K-12 data science landscape, and that you appreciate hearing about an example of data science being infused into a high school classroom and how those students reacted. We also want to share some resources with you to inspire you to complete your own investigations, and we'll allow some time for your ideas at the end. So to get us started, we want to see what you all think about data science. So drop some words in the chat that describe data science in your mind. No wrong answers, anything that comes to your mind.
It is called as chat storm.
Yes, so storm the chat with words and ideas. We've got some awesome thoughts out there. In the Diffuse project, we've defined data science as drawing from mathematics, statistics, and computer science. It's a multidisciplinary field using scientific methods to gain knowledge and insights from structured and unstructured data. So what about data science in K-12 education, past, present, future, in elementary, middle, high school? What's going on there? In the past, when I was in school in K-12, there was no probability or statistics. But this is a new century, and Common Core infused some probability and statistics into mainly middle and high school. The Common Core framework, adopted by most states, now being revised in a lot of states, hopefully to include more data science, relied on the original GAZE report, Guidelines for Assessment and Instructions in Statistics Education, which was published in 2005. We saw measures of center and variation, distributions, box plots, contingency tables, lines of best fit introduced at middle school. Presently, we need more data scientists, and we need our high school graduates to be data literate. Statistics and data science is more than math and analyzing numbers. We have to ask questions, collect and clean and consider data, and communicate the results. Communication is especially important. Some of you might be familiar with this four-step process, the statistical problem-solving process that is used in the free GAZE report. There's a link on the slide to the GAZE 2, which was updated in 2020 and is jointly endorsed by NCTM, National Council of Teachers of Mathematics, and ASA, the American Statistical Association. Like the original GAZE report, it includes a framework for levels A, B, and C, which are generally aligned with elementary, middle, and high school. These levels are sequential because statistical concepts like the standard deviation take time to develop. So for some concepts, even an adult might need to start at level A. If they're only used to measuring the center and not the spread or the variation, they would need to start from the very beginning. So curiosity is key, and we want students to question throughout the process. When you start creating a graph, often it leads to more questions, and you might need to collect more data. The process is not necessarily sequential. You might shuttle back and forth between steps, and you might start by considering data that has already been collected. So there are some data science courses in schools already, and in the future, you can expect to see many more. You'll see more data science, not just in math classes, but included in other subjects, science, social studies, language arts. Future trends include an increased use of AI and machine learning, as well as personalized learning experiences. Anticipated changes include a greater emphasis on data ethics, real world problem solving projects, which we're going to show you a great example of one, and you'll have full access to everything, and cross disciplinary applications. So I am going to hand it over to Merve to talk about the Diffuse project at Dartmouth College.
Okay, hello everybody again. And today I'm excited to introduce you to NSF-supported Diffuse project at Dartmouth College. On the slide, you can see the link, which is a YouTube video, and it's a film about our amazing project Diffuse. So feel free to watch it later. And so Diffuse stands for Data Science Infusion into Undergraduate STEM Education. The primary goal of this initiative is to integrate data science into introductory courses across STEM, and also I'm highlighting that part, social science disciplines. An example might be an undergraduate environmental science class. The instructor may not have an idea how to use the data, or maybe under-resourced, but may not have the also data science skills to create analysis tools. So we partner with them and develop tools so the students can investigate different phenomena. And at Diffuse, let's see what does the project aims to do and how it helps students. We want to see if early courses can introduce students to data science, increase their interest in further data science studies, and prepare them for workforce, which is really requiring amazing data science interest and the skill set in the future. So we create and test specialized modules with faculty and evaluate student response. So Diffuse seeks to show how students like Diffuse seeks to show students how data science can be applied in different fields. And not only students, maybe I shouldn't narrow it to the students, and also faculty and instructors and anyone who is interested in data science, in helping them to understand its value, even it is not part of their primary fields of the study. So for that, we have been providing professional development for faculty and instructors in the last 2 years. So when we employ modules in classroom, we aim to teach students some of the skills that are necessary for data scientists. And take a second and look at that slide. And these are gathering and cleaning data, extracting meaningful insights, in interpreting the data, making informed decisions. So these are the general we call them competencies, but the main things we want the students come up with that at the end of this module. Being exposed after this module deployments. So, and then the Diffuse provides a flexible and reusable set of tools and resources. Some of this simply use a spreadsheet for data analysis, whereas others are using more advanced technology like programming, including R, Python, and so on. So to make these resources widely accessible, we have created with our teams a GitHub repository where they are all stored. These resources are available to everyone. If you're a teacher or instructor, feel free to use them in your class to incorporate in your classroom. And parents who want to introduce their children to data science can also access our resources. So in summary, I can tell that Diffuse project aims to broaden students' exposure to data science, improve essential skills, and provide adaptable tools for educational use. And in our next slide, so here for the high school application of Diffuse, we selected a module. The mathematics were accessible to younger students and developed a lesson. And feel free to explore the details of the lesson and use anything from it through the link on the slide. We also surveyed and interviewed students to understand their knowledge, attitudes, and beliefs. A pre-survey was given before the instruction on 2 quantitative variables. After completing a module, a post-survey was conducted, and we used these results along with the student work to select 3 students for interviews. So, I would love to introduce briefly our MVS3 module, Environment and Society. The MS3 module for Dartmouth's Environment Society course explores the links between COVID-19 death rates early in the pandemic and different variables. Feel free to check it using the link or QR code on this page. Like this will be like lead you to the website of the tool. And in this module, we use the word Cancer Alley. So diffuse team chose this region due to Cancer Alley, a highly polluted corridor along Mississippi River from New Orleans northwest. The instead map shows EPA cancer rate visualizations with Cancer Alley in bright red, indicating elevated cancer rates and respiratory health risks. This made it valuable area for investigating potential links between pollution and COVID-19 mortality. And it's not limited variables. There are more variables, and you can see on that slide. And this rich data set includes many different variables, including demographic and environmental factors. It took a tremendous amount of effort, create, and you can see that data from many different resources well documented. And the module features three visualization tools. First, the interactive map, and it displays that race across graphic areas shaded by different variables. And next, the correlation matrix shows the associations between COVID death rates and other variables. And finally, the linear regression provides scatter plots with linear fit equations and R-square values. So by seeing all of this different visualizations, students and learners, that can be anyone, will be also exposed with different version of this, playing the ways they can play with the data. And these tools help students explore statistical methods and mathematical modeling adapted to their level of time constraints. In our next slide, in our high school lesson, the students worked in the groups complete the statistical problem solving process. And they communicated their results by creating a poster to submit ESA high school data contest. So here's an example of work for students we interviewed. Evangeline's group, the first one, and used each of the three different the visualizations from the module, whereas Emily and Jay groups compared maps and regression plots for different waves of COVID. So we just asked the students, with their groups, create this amazing posters, and we had we made them to walk and see each other and criticize each other in the classroom. So the survey results. What did these high school students think about this? First, we look at the survey results and then the interviews. In our surveys, so overall students' feedback on diffuse module was very positive. Most students valued data science and were interested in working with data and found the skills important for their careers. A key finding was a shift from pre to post survey. It's really important to highlight. Students' excitement for presenting data grew while their interest in data analysis decreased. This suggests a need to adjust our approach to align with our changing interests. So, students enjoy working with multivariate data sets and felt confident, which is great. And also, they face some challenges. It is also great. Uncertainties, challenges are great. It means that there's learning there and questioning there. So many preferred focusing on communicating results over analysis, highlighting the need for strong data presentation skills. Post-project, student attitudes and confidence improved, moved from single variable to the two variable analysis, so showing a significant progress in their data analysis skills. And overall, the feedback from the students shows that the module had a positive impact, and they all felt the module increased their interest and knowledge in data science. Let's take a second again, look at our students' quotes, and which are really the ones really important to highlight here. We are thinking, I felt very engaged. I really enjoyed doing the work. I was very bought into it. I liked learning about it. And more important than this, she was saying that I feel like an intern. This is what we really want our kids to feel. They started to feel like a data scientist. They feel like an intern. They started to creating and playing and interpreting, analyzing. So that is the ultimate goal we want our students telling or feeling. And Emily was saying that I can think about data more critically critical thinking, which is really important again to highlight. And Jay, I like the project. I thought it gave me like more a real world application. That was the three ultimate goals of the diffuse, really, when we are trying to expose students with all of these resources we were creating for them. And I think I'm done here. Thank you, Sheri, and we can move forward.
Awesome. Thank you so much, Merve. Awesome tools and resources. Kids were really engaged in the lesson and appreciate it. So we encourage you to check it out. We also want to arm you with some resources that might inspire you to do your own investigations. So what resources beyond the GAZE 2 report and diffuse modules might be helpful for you? So here are some websites and videos. If you know of any additional resources that you have found useful, please drop those in the chat and we will try to add those to the slide deck. I do want to highlight a few of these resources. The third one down here, the website from American Statistical Association, their K-12 education resources is packed full of resources for elementary, middle, high schools. They've got lessons, they've got links to tools. They have many different competitions, like the one that we had the students enter for a visualization contest. So please check that out. Articles, there's a lot of different articles that are helpful in identifying data science to be teaching. One in particular, if you're not familiar with Statistics Teacher from ASA, it's a great resource. This is an article about photographs that can be really engaging for students. One lesson, there's some lessons on here on the STU website as well, and there's some really cool technology tools like a color analyzer that has the computer determine the color of the photographs that are included here. Spreadsheets. So what about tools to analyze data? Spreadsheets are most widely used. Here is a link to a very simple spreadsheet. I just grabbed baby names from the US Census, but spreadsheets don't really afford a dot plot with an overlaid box plot, which are now in the middle school curriculum. Thankfully, students don't need to use R or Python programming to do that. There's many free resources with the ability to analyze data that don't require any coding. Many of you might be familiar with Desmos, an online graphing calculator, but CODAP and Tuva are both free resources that were built from the ground up to analyze data. And as you can see here, they do more than just traditional graphs. You can map things and the graphs cross-correlate with your data table. So it's an area where students can play with data. Also, another way to visualize data and understand statistics is through the many use of online applets. These are all free resources, most of which allow you to input your own data and may also have some pre-filled examples from corresponding textbooks. So once again, if you know of any additional resources, please drop them in the chat. We'll add them to the slide deck. I don't know if everybody got the link to the slide deck at the beginning. Maybe we can share that one more time here at the end. You can always reach out to us as well. It looks like we are just about out of time, but it's your turn now to ask some questions, share ideas. How can we help you succeed? What do you guys think? Either unmute or drop a question in the chat.